Dear students, today class discussing the unit number 1, testing of hypothesis. Today discussing the problem in F-test. Already discussed in part 1. This is a part 2 video for F-test problem. The given problem will be two independent sample of sizes 9 and 7 from a normal population had the following values of the variables. Here sample 1 and sample 2 will be given data. Here sample 1 n1 will be 3, 4, 5, 6, 7, 8, 9. Then sample 2 n size will be 7 data now. So the estimates of the population variance differ significantly at 5% level of significance. Here asking the problem at the population variance. So directly asking the population variance mean we can use the F-test problem. At the degrees will be 5% level of significance. So first have number of data. So here n1 will be 9 and n2 will be 7 for the sample 1 and the sample 2. So I can sample on the x1 the whole square value total, and then sample to x2 the square. I can just add the value total value. The sample 1 total value will be 129 and then square value will be 1871. Sample 2 the total value will be 110 and then sample 2 square will be 1760. Just find out first. I find out the mean for the sample 1. So x1 bar the value will be 14.33. Then mean for the sample 2 the value will be 15.71. So the next find out the S1 square. S1 square is the mean for S1 square is the variance for the sample 1. So this is summation of x1 square divided by n1 minus some x bar whole square. So just substitute, got the value will be 3.33. Then S2 square. S2 square will be summation of S2 square divided by n2 minus x2 the whole bar. Just substitute, the value will be got the value. Then you should find out the capital S1 square. Here capital S1 square will be n1 S1 square divided by n1 minus 1. The value will be 3.751. Then capital S2 square, the formula will be n2 S2 the whole square divided by n2 minus 1. The value will be 5.23. So here variance for the first sample size will be 3.751. Variance for the second sample size will be 5.23. Here sample 2 size will sample 2 for the variance will be higher comparatively sample 1. Okay, so here variance of the S2 square will be higher, variance of the S1 square will be lesser. So I am taking the parameter for the sigma 1 square and the sigma 2 square. So first step I take the null hypothesis H0, sigma 1 square equal to sigma 2 square. Step 2 will be alternate hypothesis H1, sigma 1 square not equal to sigma 2 square. Step 3 will be at a degrees of 5% level of significance. The formula will be n1 minus 1 then n2 minus 1. So automatically here no degrees of v1 will be 8, degrees of v2 will be 6. So why I am taking the 6,8 mean because there's a variance for the sample 2 will be higher, that's why I'm taking the 6,8. The variance for the sample 1 will be higher, now I'm taking the 8,6. So here variance for the sample 2 will be higher, that's why you can take the 6,8. So table value for the 6,8 will be 3.58. This is a table value. Then find out the calculated value. So step 5, this is a formula f which is a higher variance. So s2 square will be higher variance, s1 square will be lesser variance. So I can put the higher variance in the numerator and the lesser variance in the denominator. The substitute got the value will be 1.3963. Step 6 will be conclusion. So calculated value will be here 1.39, but the table value will be 3.58. In the problem, table value will be higher, but the calculated value will be lesser. So automatically we accept the H0. So therefore the calculated value will be 1.39, but table value will be 3.58. So we conclude the solution that the difference is not significant because here H0 is accepted. So both the variance will be equal. Thank you.